The problem statement is given an integer array norms, integer value. Remove all occurrence of value in place, return the number of remaining elements k. We are with an given array. Now another integer it will give take 2. Now we have to remove all the elements occurring in that array. 2 is occurring here and here, right? So we have to remove this. Then what about the remaining element? 1, 3 and 4. So the answer will be 3. Count of remaining element. Read the next statement. To get accepted, you need to do the following things. What are the things we have to do? Change the array numbers such that the first element of numbers contains the elements which are not equal to value. So in that array, we have to order that element such a way that in the front we should have the elements which are not equal to the value. So the array should be 1, 3, 4. The remaining elements of numbers not important as well the size of numbers. So these things are not important, it is saying. Just we have to keep all the elements which are not equal to the value in the front. Did you remember something? Last time we have solved one question, this one, right? Here also it is showing the same thing. Like consider the number of unique elements norm to be k after removing all the duplicates. So it was saying that removing duplicates, but the unique element should be in the front. Same thing here, the question are almost same. It is also not saying to remove the value. It is just asking you to keep the elements which are not equal to the k in the front. Let's understand with another example. Assume that your array is like this 1, 4 and the value is 5. So in the end, when we remove the 5 element, when we remove this value from the array, the array should become like this 1, 3, 2, 4 and remaining element we don't need to care about that, and we are returning 1, 2, 3, 4. This is going to be your answer. Next, pattern recognition. How we get to know this is going to resolve by the two pointer. First of all, the indication are like modify array in place. Then next one is filter some elements. Keep remaining element. This immediately suggests the two pointer and same direction. Last question also we solve like that, and I have already explained how it is related. This problem also going to be solved with the approach of last question. Just need some tweaks. So I will just explain how it is going to be solved, but I will not write the code here. Let's take an example of an array and our given value to check the value is 2. So last time we have declared the pointer 1 slow in the 0th index and fast in the first index. But here we are going to declare slow and fast at the same time, at the same index, that is 0. Because last time we have to find duplicate, we have to remove duplicate, and first element can't be duplicate. First element will must a unique number. So comparing the first element with itself, it was no use. But this time we are having a value. So the value can be in the first index also, right? That's why we are declaring the slow and fast, both the pointer in the 0th index. And the fast pointer will move up to the end of the array. We can take n is the size of array, so n minus 1. So f is going to start from 0 to n minus 1. Inside the loop, what we have to check? Those numbers which are not equal to the value. The elements which are not equal to the value, we will keep in the front. So last time also we have discussed the slow pointer is to write the array, while the fast pointer is to read the array. We will read each element by fast pointer. If we satisfy with any of the element, we are going to put inside the slow one. Now we will check if that is not the value you are going to put inside the slow pointer, right? This is the loop condition. Okay. So if if what the value not equal to the fast pointer means array of fast. If it is not equal to the value, then we are going to perform the operation and we are going to put inside that slow pointer, right? So array of slow equal is going to be the array of fast. Now we will move the slow and also we are going to move the fast to we are also going to move the fast pointer to compare with the next element and slow to point out the next position where we are going to keep that. And this is when not equal to their value. If it is equal to the value, just we'll skip that fast plus plus. Let's do a dry run for it. Our value is 2, right? And this is our array. So the slow pointer, fast pointer now pointing to the index number 0. The first element is now 2. Sorry, it's now 1. We'll check whether it is equal to the value or not. So first equal to value. It came false. False means it is not equal to the value. 1 is not equal to 2, right? When it is not equal to 2, when it is not equal, this is our condition. When it is not equal, we are putting the fast pointer element to the slow pointer. So for this one, the slow and fast pointer both are in 0. Slow also 0, fast also 0. So we are going to put the fast pointer into the slow pointer. So the number will be the same only. This number will be the same because first index only we are performing this operation. We are putting 1 inside the 1. That's all. Now when it is not equal to the value, what are the two conditions we have written here? Slow also move 1 position next and fast also is going to move, right? The new array is like this only, but the pointer has been moved 1. Slow also move, fast also move, right? Slow is here also, fast is also here. Again it will check the first element equal to the value or not. Value is our 2. So the value is 2. So it is came true. 2 equal to 2, right? True. True means what condition we have written here? When it is false, when it is not equal, then we have this condition. When it is equal to that value, we have only need to move the first pointer. So here we will move only the first pointer one step extra. The first will move to here because when it's equal to that value, we are doing fast plus plus. Again, we will check the fast pointer equal to that value or not. So the fast pointer is 4, which is not equal to the 2. When it is not equal, we are going to move the element to the slow pointer, right? So this element, this fourth element is going to move to the slow pointer. So array of slow will become array of first. So the new array will become like this. Here it will be, this is the new array 1. There, here it will be 4. The 4 will be still like this, and after this operation we are going to move both the pointer, right? The slow will come to here and the fast will go to the next element fast. Again it will check element equal to the value or not. It is equal to that value. When it is equal to that value, we are only moving the first pointer. So here it will be f plus plus. That means this first pointer will come to here. Again we'll check whether this first pointer is equal to that value or not. First pointer value is 3 and our value is 2. It is not equal to. It is not equal to means we are going to put this array into this to the slow pointer. So this will again become 3 will come to here. This will be the 3 and we will move the S and F also. When we are satisfied with the condition, we are moving both the pointer. But now the F going out of this array. So here we are going to end the loop. When we end the loop means this is our answer. This is our k value. K value is how 3. 3 means how we'll get 3? S is going to give our answer, the slow pointer. So the answer will be 3 right now, and we get the desired array, whatever in condition it was saying. Understood this question? Try to write this by your own and see the previous video to get better clarity on this slow and fast pointer. This is exactly same only. Just we have to consider the cases. I am writing here the cases. What are the cases we have seen here? We are having a value, right? Value something. We are having two pointers, slow and fast. We are checking fast with the value. So when the fast is not equal to case number 1. When the fast not equal to the value, then we have to perform two operations. Put the value of fast to the slow. So array of slow will become array of fast. And here we are moving both the pointer slow plus plus and fast plus plus. And condition number 2, when case 2, when both are same, only we have to move the first pointer, that's all. And up to 0 to n minus 1 we have to loop it, right? Try to solve this question. Next video we will see the next question from 2 pointer.